Where are you? You ready? Yvette, okay, outstanding. Oops, let me get my coffee cup out of the way.
I might drink it.
I know. And the bad part is I wouldn't drink it. That'd be the real problem. Okay.
Okay. Okay, thank you. I guess I'd like to start on behalf of my group and just say that I think we've all enjoyed being part of this and interacting with people from very different disciplines from ours, and I think that's a really nice thing to do, and really makes you think about things you haven't thought about before and ways that you can connect with other people. So I think we're all very grateful for having been part of this. Oh well. Good. So I readjusted here, but so we have our 3 research projects that we were to come up with, and we've kind of just listed them each on their own slide with all of the criteria that go with them. So the first is, and this we're assuming this will probably be on some other people's slides as well, is probably our most cross-cutting interdisciplinary project that we were thinking of. And that is the idea of a rapid, independent pre- and post-event assessment system to determine readiness, response, damage, and casualties, similar to what NTSB does, using multidisciplinary teams. So we've tried to come up with an estimated cost for this, and not sure how close to on target it is, but we did our best. And we thought it probably would be about $30K per event just for the people to get there, and then depending how you want to do surveys and things, if you want to get aircraft involved, which is a good way to do it if you have a big outbreak kind of case, then you probably need another $50K or so to do that. This involves a lot of different disciplines. It involves some physical scientists, which was our group. Also, of course, structural engineers, sociology, epidemiology, economics, and perhaps some people from the private sector would also be interested in being involved. So maybe home building associations. We're not quite sure who all would want to be involved in that, but we can imagine that there would be some people from the private sector, insurance companies, things like that. This is interagency, perhaps involving the Office of the Federal Coordinator for Meteorology, CDC, Red Cross, National Weather Service, NSF, NIST, Texas Tech has some ongoing projects like this, FEMA, local police, to get access, and emergency management. So it's potentially a pretty big group of people from all different places to try to work together, which is listed as one of the first barriers, is perhaps some interagency cooperation would be needed to do this. Unless you can fund sort of a pilot project of this for a few years with maybe through one agency, which is something we were tossing around. This could potentially be started right away, and hopefully there would be some mechanism to have funds to have it ongoing indefinitely after that, but that is something that we have to figure out how to do. Other barriers, we need a pool of volunteers with the necessary skills so that we can draw different people at different times. Coordination in producing a final report when you have people from all these various disciplines, really getting a good product at the end of this assessment. And then one question we had is who will initiate the assessment process? It won't be done on, obviously, every tornado that occurs, so where will the person be housed that decides that an assessment should take place for a particular event? And that is something that would need to be figured out with some guidelines in place. And there's been a lot of talk about not just doing assessments for the most deadly cases, but also doing at least one assessment in here that was for a case where things actually went pretty well, to see what was different there and why were people more ready in that particular case. So that is our first project. Okay. The second one is aimed at reducing false alarms, which is something that came up quite a bit at the meeting, and I think we still need help to know if that's an actual really big problem that should be being addressed. But it seems logical, at least to a lot of us, that it probably is something to address. And in addition to just reducing false alarms, improving warning precision and accuracy. So, for example, maybe not determining what is the optimal distance that this warning should extend from where it's being issued. In other words, how long do you think this tornado is going to last, and how far is it going to travel? And don't warn past that if we're able to figure that out. So this involves improved understanding of meso, which means the scale kind of larger than the storm, but the environment surrounding the storm and how it interacts with the storm. That would also include interactions between different storms and whether those have an outcome of creating a tornado or causing storms to die, things like that. Storm scale processes and substorm scale processes, so things very internal to the storm at small scales that initiate, maintain, and dissipate tornadoes. And also those processes that determine tornado intensity, using both observational, so perhaps measurements that we gathered in Vortex 2, as well as any other observational data we have, and numerical modeling studies. We think we probably need both of these in order to address it, some combination of the two. The cost of this is, again, pretty rough, but on the order of $10 million. That's approximately 10 separate NSF investigations of $1 million each, plus all the ongoing NOAA efforts, which we didn't estimate a cost for, but things like the research at the Severe Storms Lab. The time, some low-hanging results could come out pretty quickly, but most of the more difficult ones would probably take 2 NSF grant cycles, so about 6 years. And barriers are a lack of microphysical and 3D temperature, moisture, and wind observations, as well as model limitations for the numerical modeling part. There are parts of the models that don't produce things in the storm that we really need them to do well in order to address this problem. So that's another thing that needs to be worked on. How much time do I have, actually? Okay. All right. And then research project number 3 was to explore the utility of new observational systems. So not necessarily all new technology, but new ways of putting together some existing technology, as well as some new technology, perhaps, for tornado detection and forecasting, including controlled experiments with simulated observations. So what we mean there is using the model to pretend that we had an observational system and see if it would really improve forecasting results or not before we invest a lot of money in actually implementing a system and buying all of the equipment for it. So exploring this would be a cost of $5 to $10 million, approximately 5 separate investigations of $1 million. That's over 2 NSF grant cycles. And really, this will require creativity and thinking of new possible observations that might be useful. Things like the network of networks that is being put together, some of the instrumented cars, just trying to really think outside the box in terms of what can we gather that would be of high enough quality to be useful to the tornado problem. So that is it. Any questions?
Hi, I just wanted the first research project, I guess I would encourage to put public health as a partner as well.
We had the CDC in there.
Right, and
Is that
yeah, I would put in there the
separate?
state public health department, because they would,
Okay.
for CDC to come in and do any human interviews, we'd have to be invited.
Okay, sure. Thank you. That's good input.
Also related to your first research project, the Earthquake Engineering Research Institute, EERI, has had a Learning from Earthquakes project for a number of years that's supported primarily by NSF but manned by volunteers. It could be a good model for what you're thinking of.
Okay, yeah, I think someone had brought that up, but that's very good. Thank you.
In the European community, especially after the Haiti disaster, there's been a significant effort to develop and improve and refine methods for collaborative damage mapping using crowdsourcing methods. And that's something that I think could be leveraged in a number of ways in a number of projects that have been mentioned here, especially Norman Curl in the Netherlands and others. Issues of, I raised this in our discussion, if you're going to go around and interview people and they're willing to be interviewed, then you've got the beginnings of a civilian damage mapping corps out there. And if there's an event, they get on the cell phone, they call a number, they report what they see when they look around. And if they've been properly instructed and trained, then you can load those into mapping products that could go right to the emergency response people. And they'll know where to send what resources.
Okay, thank you.
To another event, just to let you know, the NSF is holding an invited workshop on quick response damage surveys for pretty much all natural disasters in, I believe it's 11th through the 13th of June this year, where folks who have gone to Christchurch earthquake, the tsunami in Japan, myself, people in tornadoes and wind hazards would be discussing particularly these things. I believe the focus would have been for the structural engineers, and I will certainly raise the issue that others, CDC, social scientists, and so on, should be invited to that table.
Okay.
I like the project idea, although on the cost side, I think that is even on the low end if you're getting multidisciplinary teams for even collecting the data. Archiving the data, analyzing the data, reporting, writing reports on the data isn't even touched in your budget estimate. So,
Yeah, that is true. I guess it depends how much time people, whether this is volunteer time or whether this is paid salary time.
anyone else? Thank you, Yvette.
Okay.
Lou.
Okay, I would like to say, like Yvette, I've enjoyed my time here and appreciated meeting the cross-section of folks that I have, and I think I really enjoyed working with my team too. Thank you all for contributing in meaningful ways. So our top research project is related to defining how people perceive, receive, and act in response to tornado-related weather information, and then how can we create metrics that are then meaningful to those folks as well. We've been talking about, false alarm issues and verification of scores. They're meaningful to the meteorologists, but are they meaningful to our public? And so we suggested a project addressing that need. And so you can see the list of issues addressed there. There's several of them. We decided that, not being social scientists, most of us in the room, that we shouldn't be defining who should be working on this project or what the cost would be. It was just a little, too outside of our realm of expertise to be able to do that. So we leave that to a group who, might actually develop the project. Challenges, though, scope. This could be really huge. Okay, so and again, that would be the role of the folks doing the work to define what is the scope, perhaps for money available. And of course, that then relates to representativeness of the findings. How could you employ them regionally, given community differences? Okay. We should have done like a countdown. That was like number 1. So here's top number 2. Number 2 research project. There's a number of different warning dissemination mechanisms, as we're all aware, and there are, some issues as to which ones are most effective, how much do they cost. We might have to pull back perhaps on some of those in terms of support. So if we're going to make decisions like that, we need to understand how they're being used, who are they being used by, and how effective are they. And so that's what this research project addresses. And so you can see, then again, here's all of our issues. And I think one of the interesting one is regional situational limitations of each dissemination method and levels of redundancy that are needed. So cell phones, and we had a tornado come through Norman, and I was attempting to call my husband while I was going down to the shelter, and I could not call him. And I knew he was paying attention to the weather, but I wanted to, to talk to him and tell him to make haste if he was not. Okay, so this is just that repeated with the challenges at the bottom. Again, regional differences in reaching all segments of the population, how you define those and be inclusive as possible. And number 3. This one is a very full, all these are, I think, social science-driven types of projects. But this one in particular, understanding from a very holistic standpoint the full National Weather Service process, and with a focus on, how do these folks come together, perform their job, especially under pressure, and, have good outcomes. What are the characteristics of them? How do they interact to have high-level performance? And we can then learn from that in terms of, what makes a good organization in the National Weather Service. So this is all related to development of team expertise and challenge, possible restrictions, access to office. Maybe an office might not want us in there studying them and how their office works together as a group. So, question time. Who has something to say?
I like them a lot.
Okay.
We'll make sure we poked you on that.
Yeah.
Yeah, if you were to expand this a little bit and just say the severe storm or the tornado forecast process and leave NWS off of that, but include every other organization that's involved, did you consider that at all?
We did. We discussed that, and our thought was the holistic, would include that. When we thought about specifying that, but then we thought it would get a little bit too long. So I appreciate you, though, bringing that up.
I still like them. No, but I just want to add to that a little bit that some of these things are already happening, and to different levels, to different extents, to different. So one of the there's two kind of approaches. One is new projects that I think really could be useful and really with a broader perspective. And then the other thing is to take the existing knowledge,
build,
and translate it into operational concerns, and take the existing things that are already there and start bringing it into what's going on. And I think that in some ways, the people who are really good at those two different things are not always the same people. And sometimes the people that are really great at creating new knowledge are not the same people that are really great at operationalizing existing knowledge. So in some ways, I think that, especially given the push that I've heard from several NWS folks about doing something right now, immediately, that starting to build off of what we already know and make some inroads is really important, and then to seed new ideas to continue that flow with the projects that have expanded scope. So just
Yeah, that's a good point. And if new things are implemented, perhaps that could be a part of this, where you're studying. I think it's this one, yeah. Where you're studying the holistic process and something new has come in, and that could be, perhaps part of what's measured as well. More bang for the buck.
Green.
Okay, we took a somewhat different tact on this. We actually ended up with one project in the end, but we wanted to first of all point out that there's previous work that's been done that frankly some of us in the Green Group had not heard about before. Some people in our group had, and we really want to urge that previous committee-based efforts have come before us. NOAA's Social Science Review Panel in 2003, NOAA's Social Science Working Group 2009, integrating social science into NOAA, planning, evaluation, and decision-making, and then the National Research Council, When Weather Matters. Now, the interesting thing in most of these reports, the first two, the term social science is tended to use as a single term. In the last one, social science is equated with socioeconomic status, which we found a little bizarre. And social science is more than demography and socioeconomic status. But we pulled out a couple of extracts from some of these things. This is from the 2009 report. This is one of their recommendations. Until a coordinated and comprehensive social science capacity can be sustained, NOAA-wide, a strong centralized social science presence will be necessary, et cetera, and notice that we put in our suggestion from Tuesday, having an Office of Human Dimensions of Weather. And then the NRC 2010 had 3 sets of recommendations. One had to do with valuation. What are the impacts of current weather forecasts? How do weather and weather forecasts interact with socioeconomic structure? See socioeconomic. How do the benefits of improving forecasts, et cetera? And then, what's happening here? User needs, interpretation, and use. What makes various populations more or less vulnerable to severe weather events? How can they improve weather information, help mitigate those vulnerabilities? And then last, communication information. How do people integrate weather forecast information gathered from different sources to form risk perceptions and resolve perceived information conflicts? So, just some examples of what were in there. On Tuesday, we had one of our recommendations was that high-impact weather research should acknowledge, learn from, synthesize, and build on existing knowledge, approaches, theories, concepts, measurement findings, etc. And so we went through and then sort of worked through some of this. There are tons of social and behavioral science concepts and theories, and we've just written down a few here: team effectiveness, fear appeals, social influence, normative effects. There's a lot of hazard-specific social and behavioral science approaches and findings, for example, from hurricanes, earthquakes, floods, and wildfires, and that really relates to what Joe was just saying in answer as a question for the last presentation. RFPs should encourage use of multiple research design approaches, data collection methods, and data analysis methods. Some of the multiple methods that we list here are formative evaluations that involve focus groups, cognitive interviews, and it can also involve lab experiments. Experimental designs in the lab, web, field, true and quasi-experiments, survey and interview methods, content analysis, observational and field studies, existing records or data from administrative records that were possibly collected for different purposes, simulations and visualization. Research design issues that need to be considered are the representativeness of samples, and we've listed here 3 examples of samples going from the weakest to the strongest: convenience samples, purposive samples, and probability samples. And probability samples are the only ones that you can infer from a probability sample to a larger population. Another caveat here is correlation does not equal causation. If there's a correlation between fatalities and false alarms, that does not mean that false alarms are causing the increased fatalities. And then we went to, quote unquote, our specific idea, limited field observations, and we focused on impact-based warnings here. Limited field observations were conducted during the Joplin Service Assessment. This is valuable, formative information, but that's not where research stops. What needs to be done next by experts in our Office of Human Dimensions of Weather Research Center is to review and synthesize past literature, for example, risk, warning, labels, communication, fear appeals, public health, other environmental hazards, determine the geographic scope, population sampling, generalizability that one wants to consider in a study, consult with information providers, for example, National Weather Service forecasters, to elicit their expert knowledge and capabilities, develop test messages, subject them to expert review, pre-testing messages in lab settings with members of the public, preliminary analysis, and then what we call rinse, repeat, and refine. In other words, this often goes through multiple iterations until you get the kinks out of the preliminary formative research. Then limited field application, similar kinds of process, but now more with the public. Scientifically evaluate through process evaluation, and by process evaluation, we mean looking at when these warnings actually get used in fact, that you try to evaluate whether they were used as intended, whether they got to the people that they were intended to get to, and how they were used by TV and radio as well as weather forecasters. And then members of the public's receipt, perception, response, other outcomes, deaths, injuries, damage, disruption, etc. So this is really like a 4 or 5 part study that we're suggesting, with the last stage being essentially field surveys in communities. In terms of costs, we estimated costs at $1.8 million. Actually, we had $3 million originally, and I personally said, I personally think we should have stayed at $3 million, particularly when I saw the costs on some of these other projects. I will point out that $1.8 million or $3 million is far less than the value of one statistical life, estimated at $6 to $8 million by U.S. federal agencies. So if you want to save lives, you need to be thinking about how many you want to save and what you want to put into trying to save those lives. We figured the core staff was at minimum principal investigator, co-principal investigator, an advisory committee, and 4 grad students. I would probably have a larger staff than that. We figured a 3-year project, with the first year being the literature review, the formative research, developing messages in labs, testing them, etc. And then in years 2 and 3, testing of the new message in 3 sites compared to testing of the old, or leaving the old message in 3 other sites. So we'd have both a, we'd be able to compare between the old message formats and the new message format. Why do we need this? We need this because we don't have any baseline information. If we had baseline information, we could compare back to baseline, but we can't. Our thought was that you would take 6 communities that experienced an event. You would be working with the NWS forecasters and media and EM partners, and you'd be doing public probability-based community samples. We said a sample size of 300 in each community, differentiated between those who were affected by the event and those who were not. So we had some comparison there on what they got in the messages or didn't get in the messages. Telephone surveys, and as I said, stratified by weather impact. 300 small. You can't get into subpopulations. So if we're talking about communities that have a lot of disabled or other things, you're not going to be able to look at those with just 300. So that's it.
Yeah, again, I just wanted to point out that using, and I'm sure you'd agree, the fact of having public health along with working with partners, and especially because of the communities, typically they have the public information officers that will be pushing out public health messaging during disasters.
Great idea. I don't know why I didn't think of it. We had too many ideas going in our group, frankly.
Do you see any ethical concerns where you're talking about testing people in terms of new versus old warnings?
I advocate that institutional review boards are there for us to clean up those kinds of issues. I use them all the time. In my last national survey, I had to go through 4 IRBs, University of California, University of Colorado, University of Maryland, and the Office of Naval Research.
But you kind of glossed over your development of these new warnings.
That has to go through, all those things have to go through IRBs.
But if you have pre-existing evidence that one is better than the other.
We don't have pre-existing evidence. I don't have any pre-existing evidence.
Okay.
This is the NOAA wanting to develop a new policy, a new warning system, and going about trying to test the extent to which that is doable and viable and to be recommended.
Okay. We'll leave it to the lawyers.
Oh, he's right next to me. Oh, Robert in the back, and I see Brad up here. No, Brad's first. You're closer.
Yeah, Linda, acknowledging and setting aside for the moment that emergency managers seem to focus on all hazard response, multi-hazards. How comfortable is your group with a focus strictly on, say, the tornado warning and response process and interacting with program managers? And I think Dennis Winger may have already left, I'm not sure. Oh, he's here. At NSF, I've come to appreciate that the social scientists seem to prefer a broader, inclusive approach, sampling public behavior around a bunch of hazards. By contrast, the physical scientists, folks like me, what I have in common physics-wise with an earthquake researcher is not a lot. So to get to the question, is your group proposing to and comfortable with a focus strictly on the tornado phenomenon?
Well, I think that and I'm speaking broadly for the social science community, I mean, we've done it both ways. I mean, most of my research has been focused on earthquakes and warnings for earthquakes. And, no, we don't have warnings, but how people respond to earthquakes. But there's a lot of research out there that's been done with floods, that's been done with hurricanes, wildfires. And I think we all advocate a multi-hazard approach, recognizing, though, that there are some specificities for different kinds of hazard events. Does that? Yeah.
Who's next, Dr. Brooks?
Robert.
It's spleen vent time. In a number of these things, we've been asked to talk about obstacles. And I think, in my experience, one obstacle is the IRB process. The IRB process, appropriately and understandably, involves protecting the rights of the research participants. That's very important and cannot be emphasized enough. But the IRB process, as it was originally designed, was oriented primarily toward medical research. When we interview people about weather, or when I do my cognitive experiments in the psychology laboratory at the university, I'm not taking blood samples. I'm not providing electric shocks to small children. And for those who have to go through the pain of taking the IRB certification course, there's lots of valuable, necessary, crucial, and ethically responsible information there. But the IRB process has created a great deal of difficulty in lots of projects, especially when academic IRBs sort of dither around with details that really aren't their purview. There is some motivation going on to allow certain kinds of research to be completely exempt, although people still, of course, have to be informed of their rights. They have to have consent and debriefings and so on. The process could be significantly streamlined. And that should be done, and I hope to see an increasing momentum to do that. in a collaboration, of course, with NIH and other government agencies.
I think that's a whole different topic. I mean, therein lies a discussion. I don't do research on my campus at all unless I get IRB clearance. So, and I've been there, done that.
Yellow.
Good morning. I'd just like to say that the yellow group was extremely awesome. And I sure enjoyed working with them, seriously. These are the three topics that we came up with, specific kind of research proposals. The first one, effective past tornado warning experience on response to future warnings, was an outgrowth of the concern about false alarms. But we decided that false alarms are just one type of experience. And what we'd really like to do is include that in there, but look at some other experiences too. Second is preference for and feasibility of alternative protective actions in tornado threats. And the idea here is to look at the range of options that people have. Some people have more response options than others, and hopefully have maybe help what we learn from that have some implications for designing a more weather-ready community. And then finally, a bit different from the first two, has to do with a feasibility study for a national standardized disaster mortality surveillance system, so that there would be better data more readily available for researchers who want to use this as a database. This is the first one, and it just kind of describes some of the issues, fleshes out some of the issues that we're going to be trying to do here. That is, includes the effect of false alarms, but also includes other experiences too. That is, there are different ways, obviously, that we can conceptualize false alarm and operationalize it in the study. We would, at a minimum, do it the way the Weather Service currently does it, but would expand on that too, including trying to figure out what the public considers a false alarm and what they don't. Document different experiences that people had, both within the warning polygon and outside of it. Try to assess the frequency of warning with and without hits. Look at how these others are sort of covariates. We may look at how responses vary depending on housing type. That is, whether or not the effect of false alarms is different for people, or the effective experience is different for people who live in mobile homes as opposed to site-built houses. If you have some indication of the severity of the threat, whether maybe there's a different effective experience during the warning process, if for worse tornadoes than others, and then in terms of the tornado effects, and that has more to do with how to measure what we're going to conceptualize as the experience. And then finally, also, we'll be making sure that we find out where people were getting information, not just from their weather radio. These are the kind of things that we think we would do in terms of data collection. Some of it's a mix of methods. Some of it has to do with sample surveys. Some of it has to do with in-depth interviews. And there's also a component with laboratory simulation experiments like we talked about when our group reported the first time, where we try to simulate the warning process that people would be receiving, and we could vary things systematically there to see the effect that they would have. We also think this is probably the best way, most realistic way of getting at determining the quantitative threshold for the number of false alarms that people might be willing to tolerate before they stop acting the way that they might need to. We're going to try to do this both with some pre-event and post-event data collection. And with the pre-event stuff, this would give us some baseline data in some communities that we would pick out and think have good chances of coming under a warning sometime in the next couple of years, and then sit back and hope they do, and then go in and collect data after the fact to see what happened. We've been pushing this concept of multidisciplinary research, and I don't want you to think that social scientists don't want to include the atmospheric scientists, so we would include the atmospheric scientist involved as a senior researcher in this sort of thing to help us design the stuff and interpret the results too. Finally, This is not quite finally, but this is what we think it would produce. Provide some guidance for the Weather Service and emergency management, decided on thresholds for issuing warnings so that you don't overwarn. Instruct the Weather Service and local government in educating the public about the necessity of false alarms and appropriate response. That is, if you need to explain what happened, which was different than public expectations, we think we can learn something from this process that will help you do that. Quantify public tolerance for false alarms, and provide some guidance for the media in communicating the threats too. We thought we were being expensive until I saw those other proposals. You know, we were trying to whittle things down and apologize for it costing this much. But, you know, our estimates for this would be $400,000 to $750,000 over 3 years. Most of it is data collection, and most of that is in the first 2 years. And in terms of obstacles, not to the research, but to implementation of those products that we think that we produce, that basically requires some institutional want to, you know, on the part of the Weather Service in particular. The second project has to do with alternative protective actions, that is the range of different sorts of things, and we haven't tried to list them all here, but going to doing nothing, to taking, you know, looking for the safest place in your own home, all the way going up to evacuation to a public shelter, leaving your home to go to a building that you think is better than your own home. And the idea is to try to understand the kind of factors that would lead people to do one of these or another, or if one is better than another, then the sort of factors that would be necessary in order to get people to do it. So it would assess the individual and household preferences and likelihood of taking these different sorts of actions. We would try to assess the effect of the availability of options. Obviously, if there are no options available or they're more limited, then the likelihood of using is different. Earliness of the warning, spatial specificity of the warning, anticipated tornado severity, again, housing type, and demographics, which I'm using very broadly to just include population characteristics, which include people with disabilities and so forth, as opposed to those who don't. It would use the same types of methods that we described earlier, including simulation experiments, household interviews, large sample surveys, as well as in-depth surveys in this case. We would also have, you know, one of the possible outcomes of this is to design, if we're talking about the kind of things that you would need to be able to provide the kind of, all of those options to people, it's possible that the data would suggest that we would need some community shelters, and we'd need to figure out how to distribute them optimally given the population distribution in a couple of test case communities, and how far people are willing to go or capable of going, and so forth. So the idea is that, you know, this would be a larger group than there was in the first group in terms of the kind of expertise that we think that would be needed in this thing. We would try to come up with findings in this case that would help design a more weather-ready community in terms of things like having tornado shelters, how many, and where they would be, how to educate the public more effectively about the range of options and what they would need to do, and other sorts of preparations that the community level might need to do. So the end user of this is not just the Weather Service, but the community as well. And with this one, it's a similar price range, same sort of time frame, but implementing this potentially would cost a lot of money. That is, if you're going to build shelters, for example, someone has to pay for that. And there could be some other, there would be a lot of work after we came up with our recommendations to figure out with the sorts of people in the community level who might potentially be able to use them, how to operationalize that from one community to another. And last but not least is this feasibility study to figure out how to develop a national disaster mobility surveillance system. Basically, there are a lot of different folks out there with data that deals with mortality in disasters, but there's no systematic way of getting it all together, and as I understand it, no requirement that the data be reported in all cases, or at least to a place where it would show up in an obvious way to disaster researchers. So the idea here is to try to look at the capacity of different organizations, first of all, to be able to manage this kind of data if it were to become available. There are a number of models out there for people who collect some of this sort of data, and the idea would be to approach them, find out how they do it. You know, some of us would be interviewing them. You see some acronyms on here that I'm not sure what they are, but we have people in our group. We have yellow people who can tell you what they are, though. And so it would involve some literature research to begin with, some archival analysis to document the procedures and budgets that those different model agencies are using currently, the kind of legal constraints that there are for data sharing, interviews with key informants, which would mainly be people who either could use this data or the people who are managing it and collecting it right now, stakeholder meetings like this one, but probably smaller, and then preparing some sort of report on what would be feasible and what would be necessary in order to do it. And then it would be to recommend whether or not to establish such a system. And if the recommendation was to establish it, then it would be to identify the steps to implementing it. And this would cost a little less than the others. This would not be to maintain. This is not the cost of maintaining it and operating it. This is just to establish how to do it, whether or not it's feasible to do it. There's some organizations that probably are not going to be enthusiastic about making their data available, and there might be legal constraints to some of this data sharing because it obviously has to do with health effects and mortality and so forth. So that is it.
Questions,
comments? One thing we were talking about yesterday that I think we forgot to talk about today for the second project was the fact that we would be including economists as a part of the larger group, and that optimization model would also include kind of cost-benefit analysis of different kinds of protective action and sheltering options.
You're exactly right. I apologize for leaving that out.
Is red the next color or is orange the next color? Orange, orange, orange. What can I say? Here you go, Chris. Thank you.
Again, I'd like to reiterate what a lot of the previous speakers have mentioned. It was really great getting to know some new faces and reconnecting with old. I think it was really beneficial to all of us to learn from our colleagues in other supplementary areas. Having said that, let me remind you that this group was tasked with looking at 3 of our white papers. So we found it to be very hard to try to prioritize our research projects. So we're just going to present them in no particular order, no priority for these. In fact, we have a slide with 5 alternative projects that we're going to talk about as well. That's the benefit of having such a multidisciplinary group to begin with. So having said that, I'll start with our first project. We decided to think about problem statements and research projects. One of the things that we mentioned previously was the idea that there are a lot of assumptions that are being made. There's an assumption that pre-event planning is going to lead to resilience. Where's the data? So this first project is one way of looking at that. There are a number of different efforts out there that are pre-existing, that they're currently being developed and they're currently being deployed. One example of these is the storm-ready communities that are being, this is a program that was developed by National Weather Service. There are others that are more community-driven, as we heard from some of our emergency managers. But currently, there are almost 2,000 communities that have signed on and been ratified, certified as storm-ready communities. So to use the term that another group was using, we have a pre-existing test bed that we can actually look at these communities when disaster strikes, and we can determine whether or not there is going to be a difference in post-event recovery. So having said that, remember that one of our papers was specifically associated with disabilities. We had to also remember that we should be looking at inclusiveness in these planning events. So again, we have to recognize that the ADA, Americans with Disabilities Act, has to have an impact on these planning events. So what we proposed to do was to look at archival data in a cross-sectional fashion. Go out there and access pre-existing data that tells us, okay, this particular community was certified as weather ready, this one was not. What are the differences in recovery? So that would allow us to answer quite a few questions. What's the speed and quality of recovery? Does this event planning actually matter? Give us some empirical data. What are the long-term effects for compliant versus non-compliant communities? These are all things that we could look at. Do you see discernible differences in variables such as loss of life, injury, and property loss by these different community planning situations? Now, in thinking about implementation of such a project, we were using the criteria that we were given, I guess, in round 2. We were thinking about resources, and we really didn't get to the point of putting actual dollar figures on here. We just went high, medium, and low. It gives us wiggle room. This is consistent with Ray's idea that how much money do you have, what can we get? So we're talking about high being excess of $1 million and low being less than $500,000, with medium being in between, obviously. So this would be a relatively inexpensive project. We're talking about archival research where a lot of different stakeholders, a lot of people from different disciplines such as city and regional planning, economists, emergency management folks, public policy, could go in, access this data within a number of years, and that's what would allow us to answer some questions. Time to implementation and time to completion, a couple years to do this. Our impact that we were really focused on, again in the tradition of NSF, is to think about, does planning really improve recovery? That would allow us to answer this question, and in fact, it would tell us whether or not this was one approach that was successful in building our weather-ready nation. Okay, so barriers to success. We talked about difficulty of accessing archival data. Again, there are legal issues, as the last speaker told us. Some people may not be willing to share that data. There could also be missing documentation. Other considerations we would have to think about recruiting people that are public works professionals in terms of how we might alter different options within these planning situations. So that's one study that we talked about. A second study is very similar to what I've heard a number of other folks talk about. Specifically, we want to examine tornado warnings as a process for various subgroups within the population. One of the things that came out in the first talk up here was the idea that we know something about how people with disabilities fare. We know something about how elderly fare during various types of hazards, but a big hole in the literature is that we know very little about what happens to these vulnerable, underserved populations during tornadoes. So this is an effort to fill that gap. Specifically, we want to know things like how does the effectiveness of warning content, how does modality of delivery, source of information, whether or not it comes from a trusted source within the environment, how is that going to vary by community subgroups? Specifically, we would be looking at people with disabilities, elderly, English as a second language, and folks that are low SES. So obviously we would have to employ a nice sampling technique, as Linda was telling us about. So really we could measure all of this in terms of receipt comprehensibility of message content and likelihood of protective action compliance. But really we're going to propose two stages here. The first stage is obviously, do differences exist amongst these different subgroups? If differences do in fact exist, is it enough to say that these existing messages are bad? That's easy. Everybody can throw stones. What we have to do is we have to go a step further and talk about how we can improve the situation. So what we're talking about here is the development of new warnings that are going to be not only accessible to these subgroups, these underserved groups, but also is going to utilize participatory design. That is, rather than creating something for these people because we know as an expert what they need to hear, we should go to them and specifically ask them, okay, what is your input here? Do you understand this? Is this wording appropriate? If not, how should we alter it? And again, we're talking about an iterative process. So, as you can imagine, when we start to examine this particular project's criteria, this one's going to be a little bit more expensive. It's going to have a lot of different personnel. It's going to take a little bit longer. In fact, as you can see up there, medium to high, we're looking at including people from social work, psychology, communications, meteorologists, disability specialists, gerontologists, lots of different folks that would allow us to work with these various groups. Now, the impact of this would be that we would develop more accessible and more effective tornado warnings. Of course, the barrier that you always have to consider when you're doing this type of work is that you have to get the community on your side. How do you access, how do you recruit these people from these different groups? So obviously we would have to look at mechanisms for getting in with these target audiences. Community action committees, for instance, are a great example of getting people in the environment, leaders in that community, involved in helping you recruit folks to work with you. So that's a potential barrier. Other considerations we had to consider is the idea that we are looking at dissemination of information. As a number of folks in our group were very vocal about telling us, technology changes. That's something that we all have to consider. So we have to be relatively adaptable in this study and realize that, you know, we may get into studying this and there may be future types of technology which we should incorporate in terms of dissemination. So that's something we have to consider as well. And a long-term goal would be that these results might generalize to other hazards as well. So, interesting topic. Third, last, definitely not least, remember these are not in any particular order. We were specifically interested in looking at cost and level of protection of safety rooms or tornado shelters. As we talked about pretty extensively in that first talk, there's a lot of guidance on what constitutes a safe room, a tornado shelter, with, I guess, the pretty extraordinary assertion that it provides absolute protection from death and injury, or near absolute. That's something that just begs to be studied, obviously. But it's a high construction cost that's going to get us there. So $8,000 to $12,000 to get to that near absolute protection. Obviously, this has led to limited adoption. So one thing that screams out at us is this idea that we should be developing new combinations of lower cost alternatives. Not everybody's going to be able to afford the Cadillac of safe rooms, as we've talked about. Are there different combinations of alternatives that will result in broader adoption? Are there lower cost alternatives that will provide a percentage of protection? What are people willing to adopt? What are people willing to spend? These are all things that really need to be investigated. Of course, the idea would be that with the availability of these new combinations, we would probably see wider spread adoption of this construction. So looking at our criteria for adoption, this is something that would be relatively expensive as well, medium to high. But it would include, again, economists, structural engineers, emergency management, architect, communications to talk about how we're going to communicate these different options to populations. Should take 2 to 3 years, with our impact being that it should result in increased adoption of these safe shelters over time. We really thought about barriers to implementation, and we really had a difficult time identifying these. In fact, they're pretty minimal. This seems like a pretty straightforward topic. As I said, that's very rare, so that made us cautious about making that statement. But other considerations